For this question, I'd like to start by addressing a very common mistake that people make and also how to avoid that mistake. So the question wants to know whether some integer p is divisible by 5. What a lot of people do when they look at the statements is, okay, statement 1 tells us that it's divisible by 10, and anything that's divisible by 10 is also divisible by 5, so that gives us a definitive yes, and it is sufficient on its own. And statement 2 tells us that p is not divisible by 15, and of course if it's not divisible by 15, what I'm about to say is wrong. If it's not divisible by 15, then it's also not divisible by 5. And therefore statement 2 gives us a definitive no, and it is sufficient on its own. So how to avoid that mistake? Well, if you believe that each statement is sufficient on its own, and they're giving us different definitive answers, right? That was what just happened here. Statement 1 gave us a definitive yes, and statement 2 gave us a definitive no. You've made a mistake. You know that you've made a mistake. Why? Because the statements are not allowed to contradict one another. If statement 1 is sufficient in your opinion and gives a definitive yes, then statement 2 has to at least allow for the possibility of a yes. Which means if statement 2 allows for a no, then it's not sufficient because you're guaranteed that it will allow a yes. Why? Because, well, according to you, statement 1 was sufficient on its own and gave a definitive yes. So statement 2 has to at least allow for that. Okay, so if you know that, and if you realize, wait a minute, I'm thinking that statement 1 gives a definitive yes and statement 2 gives a definitive no, that can't be right. I must have made a mistake. So the correct way to evaluate these statements is, well, what I said about statement 1 was true. Any number that is divisible by 10, if you imagine the prime box of that number, what will it have in it? It'll have at least a 2 to the power of 1 and at least a 5 to the power of 1, and it may have more things, right? So 2 to the 1, 5 to the 1, ... We wanted to know whether it's divisible by 5. Well, look at the prime box. It has at least one 5 in it. Yes, it's divisible by 5. So statement 1 is sufficient on its own, gives us a definitive yes. Statement 2 tells us that it's not divisible by 15. So how do we think about in terms of prime box? It's telling us that we won't find both a 3 to the power of 1 and a 5 to the power of 1 in the prime box of p. It may have one but not the other. Right? It might have a 3 to the power of 1 but just no 5s. It might have a 5 to the power of 1 but no 3s. And it might have neither 3s nor 5s. So all of those are possible. The only thing that is excluded by statement 2 is we're not going to have both 3s and 5s in the prime box of p. So does the prime box of p have a 5 in it? I don't know. It might, but it might not, right? It might just have 3s, in which case we're guaranteed there are no 5s. But if it doesn't have any 3s, it can have 5s. So statement 2 is not sufficient on its own, and therefore the correct answer is A.
If you found this video useful, go to quantreasoning.com for a lot more where that came from. You should also click that like button and let me know in the comments below what you'd like me to make future videos about. And of course, if you haven't yet subscribed, go ahead and do that and click that bell below so you get notified about future videos. See you next time.